Hi, this is Frank from Intel Minds, and today we're going to be talking about 2.2 water from the IBDP program. And the main understanding is that water is the medium of life. First off, we want to talk about the structure of water. So, water is composed of two hydrogen atoms and one oxygen atom and is bounded covalently. And this gives it the molecular formula of H2O. The covalent bonds involve electrons that are not equally shared due to polarity, and oxygen has a higher electronegativity as it attracts more electrons than hydrogen. Shown here, the electrons are seen much closer to the oxygen atom rather than the hydrogen atoms. When compared to this diagram that shows no electronegativity, we can see the differences in distance between the electrons from the hydrogen atom versus the distances from the oxygen atom. Oxygen overall has a delta minus charge, which is electronegative, and we also see hydrogen with a delta plus charge, which is slightly positive. So the charge differences that exist across the molecule allows water to form associations with other polar molecules, and the slightly negative poles will attract the slightly positive poles. Furthermore, hydrogen atoms can form hydrogen bonds to fluorine, oxygen, or nitrogen atoms due to its dipolarity. Let's focus on hydrogen bonding now. So hydrogen bonding occurs when hydrogen bonds to another substance or molecule. For example, water binding to water due to hydrogen forming associations with the oxygen atoms of other molecules. So polar associations with other charged molecules are possible due to the dipolarity of water molecules, as water can form hydrogen bonds with other things or itself as water molecules. Water also has three main properties that we're going to be discussing in this video, which involve the thermal properties, as water can absorb high amounts of heat due to its hydrogen bonds, its cohesive/adhesive properties, as water sticks to itself, known as cohesion, and other charged substances known as adhesion, and also the solvent properties, which involve the fact that water can dissolve both polar and ionic substances. We want to compare methane and water as they're have two very similar structures. They have similar molar masses for 18 for water and 16 for methane, and the valent structures are both tetrahedral. However, we can see the differences in their polarity and thermal properties, as methane, CH4, is a nonpolar molecule and water is a polar substance. We know that the density of water is much higher than methane, as seen in the table here, and water has a much higher specific heat capacity as it can hold more amounts of heat per gram, has a higher latent heat of vaporization, a higher melting point, and a higher boiling point when compared to methane. The cohesive and adhesive properties of water. So the cohesive properties allows water to form hydrogen bonds with other water molecules. This allows liquids to resist low levels of external force, and surface tension allows for organisms to move along its surface. We can see down here that the water strider can move along the surface of water without actually sinking in. Also, we have the adhesive properties, as water will form intermolecular associations with polar and charged particles, which are known as ions. It allows for the capillary action during the uptake of water in the xylem via a transpiration stream, allows for nutrients to flow through water through the roots across the xylem to the top of the plant. Last off, we have solvent properties. So the solvent properties of water. Water is referred to as the universal solvent due to its capacity to dissolve a large number of substances. It can dissolve ions or electronegative atoms, polar atoms, as water can weaken intramolecular forces and result in the dissociation of atoms. The slightly charged regions of the water surrounding opposing charges will form hydration shells, as we can see here with the salt molecule, the salt crystal, NaCl. NaCl is basically made of two atoms, which consists of the Na plus ion and the Cl minus ion. So the electronegativity of water, with the hydrogen being slightly positive and the oxygen being slightly negative, we can form these hydration shells. So the slightly positive hydrogen atoms will form associations with the negative chloride ion, and the slightly slightly negative oxygen atom will form associations with the positive sodium plus ion. So we'll also be talking about what is soluble and insoluble in water. So sodium, NaCl, sodium chloride, is soluble in water. Oxygen is also soluble in water, but at low amounts. Glucose is soluble in water due to its OH group, which will form associations with water molecules. And amino acids are also soluble due to their carboxyl or amino groups that may form associations with water. Substances that are insoluble in water include lipids, as they are hydrophobic and nonpolar and do not like water, and also proteins, as they will form complexes instead, known as lipoproteins. Thank you for watching this video. Hope you enjoyed it. Hope you learned something. And make sure to like and subscribe the channel of Intel Minds.